We've been talking for the last 2 days about probability, and so far we've done simple events. Today we're going to continue with independent events, which we did a little bit of yesterday, and then we're going to talk about dependent events. So today is independent and dependent probability. Some things to review about probability is that it is the chance of something happening. The probability that an event can be found or an event will happen. It's the number of chances, the number of items out of the total number of outcomes. So for example, if we're trying to draw a red ball out of a bag of marbles, and there's 3 red marbles in there, then we've got 3 favorable outcomes, 3 chances to pick a red marble out of the total number of marbles in the bag. So say 10. So 3 out of 10 to get a red marble. We can show it in fraction form, and that's how it's normally shown. 1 over 3. 2 over 10 reduces to 1 over 5. So we can show it in fraction form, and then we simplify it as best we can so that it stays in fraction form. But we could also use a decimal, as in batting averages. For example, if you're batting, as well as Ty Cobb here, with a .3664 batting average, that means that about 3 or 4 times out of every 10, he's going to get a hit and get on base. When we're looking at weather, we look at it in percentage. Our probability comes in percentage. There's a 10% chance of rain today. There's a 40% chance of rain on Monday. So when we're talking about weather, we look at it as a percentage. Probability is going to be between 0 and 1. It can be 0 and it can be 1. It can be anywhere in between, but it's not going to be a negative number and it's not going to be greater than 1. When we are looking at the words or and when we're looking at 2 different events together, this means to add them together. Okay, so or means to add, and or a comma means to multiply your fractions together. So now we're talking about 2 different events that we are going to combine to get our probability of 2 things happening. So for example, just looking at this bowl, the probability of getting blue in this bowl of marbles is 1, 2, 3 out of 3, 6, 8. 3 out of 8 would be the chance of getting blue. And that's called the probability of a single event, or simple probability. What we're going to be looking at today is a little bit more complicated. It's 2 or more events happening. So for example, in this multiple choice problem here, this tax multiple choice, we're trying to find pop or country. Now remember, the word or means to add. So we're looking at or here. That means add. Okay, and the reason it means add is if we're looking for people who like pop or country, that means they can like either one. It doesn't have to be one or the other. They could like either one. So we're going to add those people together. We're going to add the pop and the country people together and lump them together. So we're going to add them. So in our circle graph over here, we've got this darker blue is pop, that's 32%, and the lighter blue is country for 12%. We would add those together to get a 44% chance of picking someone who liked either pop or country, either one. Okay, now to find out the probability of finding someone who either likes classical or rock, one or the other. It could be either one or both. We're going to look at this darker pink, which is 3%, and then the lighter pink, which is 25%. Add those together, there's a 28% chance that you would pick someone who likes either classical or rock, either one. All right. So independent probability then, my pointer, when one event has no effect on another event. For example, your hair color and your grade in math have nothing to do with each other. Those are independent events. They don't cross over, and it does not matter what your hair color is as far as what your grade is going to be in math. All right, so for example, if you're tossing a coin and rolling a dice, these are independent events. The coin, what you toss on the coin has nothing to do with what you're going to roll on the dice. So tossing a coin, To get heads, that's a 1 in 2 chance. We've already talked about some of this in class. It's a 1 in 2 chance you'll get heads. And when you roll a dice, there's a 1 in 6 chance you will roll a 5. Now, the word and is up here. There's also a comma in the problem. That means we're going to multiply these two together to find out the probability of flipping a heads and then getting a 5 on the dice. So that's 1 in 12. All right, the probability of flipping tails is 1 out of 2. There's a comma here. That means I'm going to multiply. Getting an even number on the dice, that's 3 out of 6 numbers on the dice are even, and I could simplify that down to 1 out of 2. Here, I'll just do it this way so you can see 1 out of 2. And that would give me a 1 in 4 chance of flipping a tails and then rolling an even number. There are more even numbers, so my chances are better with this number 2 than they were with number 1, where I had to roll an exact 5. Okay? All right, I'm going to have you do 3 and 4, and then we're going to look at the next page. 2 spinners. Now, we're using 2 different spinners, so they have nothing to do with each other. We're going to mark over here. I'm going to mark that this is blue and this is red. It doesn't really tell us which one is which because it's black and white, but since there's 2 of each, it doesn't really matter. So let's look at the probability of spinning a red and then spinning a 2. So there's 4 total outcomes here. So 4 is my denominator, and 2 of them are red, so 2 is my numerator. 2 out of 4 chance of spinning red, which can be simplified to 1 out of 2 when you divide by 2. 1 out of 2. And then to spin a 2, there are 8 possible outcomes here, and 4 of them are 2s, so that's also 1 out of 2. We're going to multiply because of the comma, and there's a 1 in 4 chance that you will spin a red and then spin a 2. I want you to go ahead and complete the rest of these on your own. And let's take a look at dependent probability. Now, dependent probability occurs when one event does have an effect on another event. And for example, choosing 2 cards out of a deck of cards. Once you have chosen that first card out of the deck, there are fewer cards left in the deck. So it changes the odds of picking the next card. Okay? You're not putting the card back into the deck. An independent event would be if I chose a card out of the deck and then put it back and then chose another one because I didn't change the number of cards for each pick. But if I choose a card out and keep it, now I have changed how many cards there are in the deck. And so that changes the probability of the second event. So let's take a look at how we would do this. So for example, we've got cards here, 2 yellow, 3 red, 2 blue, and a white. With replacing the card, that means we're going to put it back. It's still independent probability. Okay? Putting the card back is still independent probability. So we would do just the same. This word with is going to be very important. We're going to do just the same as we've been doing on our simple independent events, choosing a blue and then choosing white. So blue would be 2 out of 8 or 1 out of 4. And white would be 1 out of 8. So choosing a blue and then the next draw choosing a white, we would have a 1 in 32 chance. If we said blue or white, we don't care which one we get, that's 3 out of 8. Or we'd add them together, 2 out of 8 for the blues, 1 out of 8 for the whites, add them to get 3 out of 8 chance of getting a blue or a white, either one. Okay, same way with number 2, you can do that one on your own. And also 3, 4, 5, 6. So this is what we've just been doing. This is still independent probability. Okay, but our next example is dependent probability. With and without are not the same, so you really need to read your questions carefully. On example number 4, without replacing the card, right here, without replacing the card. I'm going to take the card out and I'm not putting it back. and then I'm going to draw another card. So my probability is changing for my second draw. For example, if I want to draw a blue and then a white without putting the cards back, I have a 2 out of 8 chance or a 1 in 4 chance of getting that blue. Now, if I have taken a blue out of the deck, that blue is not in the deck anymore. I have 1 blue card left, but I only have 7 total cards left instead of 8. So now we're dealing with a probability out of 7. To get that white card, I have a 1 in 7 chance now of getting that white card. So you can see that that changed the probability of my second draw. And so my overall probability is 1 in 28. Back here in example 3, when I put the card back, I had a 1 in 32 chance of getting a blue and then a white. When I leave that blue card out and I keep it, I have a 1 in 28 chance of getting a blue and then a white. Okay? So my odds are a little bit better on getting that white card if I keep that blue one out. All right, now also on the or side, if you want to choose blue or white, we also must change the odds if we're keeping the card. So for the blue card, I still have, let me erase this. We're going back to a new deck now. For the blue card here, I still have 2 out of 8 chance to get that. But once I take one of the blue cards out, I have a 1 in 7 chance of getting that white. I've got to add these together, so I've got to find a common denominator. And I'm just going to use 56. Okay. And I'm going to change my numerators. This one will be times 7, and this one will be times 8. All right. And that gives me a 22 in 56 chance of choosing a blue or a white in my first two draws. Okay, now I need to simplify this. This fraction is not simplified. So it's going to become 11 out of 28. So it'll be 11 out of 28 chance that I'll choose a blue and then a white if I'm keeping my cards out and not putting them back. I'm going to do one more example for you, and then I'm going to let you do the rest on your own. Let me replace this. This should say or, not and then. Okay, so on number 2, choosing a red and then a yellow without putting that card back. So on the first draw, it's the same simple independent event. And let me go back to starting a new deck. On all these problems, you're going to start with a new deck on every problem for your dependent probability. Choosing a red and then a yellow. So 1, 2, 3 reds out of 8. If I take one of the reds out, now I have 7 cards left, so my 7 will go on the bottom over here. And I want to choose a yellow, and there's 2 of them, 2 out of 7. Now I multiply. 6 out of 56, that can be divided by 2. 3 out of 28 chance of picking a red and then a yellow. Now if I want red or yellow, that means I'm going to add. So my chances of getting a red starting with a new deck are still 3 out of 8. However, after I take that one red card out and I don't put it back without replacing it, I'm going to have a 2 out of 7 chance of getting a yellow. And with the word or, that means we're going to add. So we have to find a common denominator, which will be 56. And then this one's going to be 21 out of 56. And multiplying by 8, this one's going to be 16. So now I have a 37 in 56 chance of drawing a red or a yellow on both draws, 2 draws. I want you to try 3, 4, 5, 6 down here. Remember, you're not replacing it, so you have to change that denominator on your second item. All right, we are going to work on this some more in class, and you can ask questions then. The assignment we're going to be doing is called Why Did the Actors, and it's one of your riddles pages. So be sure to complete these notes, and then we will talk about them some more.